This is my reassessment for Standard 4. In Part 1, I will be calculating the diameter of an atom in a bar of platinum metal. We start with, we have the density, which is 21.4 grams per cubic centimeters. We're giving the mass of 1 mole, which is 195 grams. And we will calculate the density using those numbers. Our density formula is the mass of one atom over the diameter cubed, and the mass of an atom is the mass of 1 mole over 6.02 times 10 to the 23rd, which is Avogadro's number. And in our problem, that would equal to 195 grams over Avogadro's number, which gives us 3.24 times 10 to the negative 22. Now we can go ahead and plug that into our density formula since we already have density. And that would be 21.4 grams per cubic centimeters, which is our density, is equal to our mass of an atom, which is 3.24 times 10 to the negative 22nd over our diameter cubed. And then we'll do basic algebra to get our diameter cubed to one side by dividing 3.24 times 10 to the negative 22 by 21.4 grams per cubic centimeters, and that will equal 1.51 times 10 to the negative 23rd, and that will be our diameter cubed. And to get diameter, we will raise 1.51 times 10 to the negative 23rd to the 1/3, and that will give us 2.47 times 10 to the negative 8. In Part 2, I will be figuring out Young's modulus for platinum. We are given that our bar of platinum is 2 meters long, and our area of our cross-section is 1 times 10 to the negative 6 meters squared. When we hang a 10 kilogram mass at the end of our bar, it stretches 1.2 times 10 to the negative 3rd meters, which is also our change in length. Now, Young's modulus is equal to stress over strain, and the stress in our problem is equal to the force over the area, and the force in our problem is 10 kilograms times 9.8 newtons per kilogram, divided by the area of the cross-section, which is 1 times 10 to the negative 6 meters squared, and that is equal to 9.8 times 10 to the negative 5th newtons per meter squared. Then we have our strain, which is the change in length over length, and the change in length in this problem is 1.2 times 10 to the negative 3rd meters, divided by 2 meters, which is our length, and that is equal to 6 times 10 to the negative 4. Then we plug that back in to Young's modulus, and which is stress over strain. So our stress is 9.8 times 10 to the negative 5th newtons per meter squared over our strain, which is 6 times 10 to the negative 4th, and that equals 1.63 times 10 to the negative 1 newtons per meter squared, which is our Young's modulus for platinum.